Well, hello, my friends. I am the ghost sitting in the room. Welcome to lesson 5.6, where we will add and subtract rational expressions. Dun, dun, dun. Here's example 1, guys. I'm not going to even fool with this. Y'all know that in order to add or subtract fractions, they have to have the same denominator. And the real process is adding the numerators, their sum over the original denominator, reduce where necessary. You guys already know that. We've done that 1,000 times since you were little. But to further our discussion of this, I want to show you how it might look with variables, okay? So we're looking at 3x minus 8 over x plus 2 minus x squared minus 9 over x plus 2. They have the same denominator. We would all agree to that. But what this literally means is that both this and that component become negative. So the end result is going to be the combination of this and the negative x squared positive 9, which we're going to simplify by combining our 8 and our 9, and you'll end up with something that looks like this: 3x minus x squared plus 1 over x plus 2. I know that one's ugly. And if I were you, I would write it with the x squared first, just because I don't like it looking the other way. All right, so that is the answer to that first one that we're working on. And they're not always going to be this ugly. Sometimes they're going to look a little less goofy. But I wanted you to see an example of something that would look like that. Maybe we can do these without having common denominators, right? Obviously, we know that in order to add and subtract fractions, you have to have common denominators. So you are going to be presented with opportunities to add and subtract fractions without common denominators. And example 2 is just like this, only creating common denominators. I am not going to do simple fractions making them all addable by creating common denominators. So if you are the least bit confused about how to add or subtract fractions that do not have common denominators, then see example 2 on your own time. That is a 5th grade reminder. I'm not doing that. But I am going to go right into example 3 with you. And example 3 is when you are given multiple polynomials, multiple terms to add together, and you have to create a common denominator. So I'm going to do a few just like this, okay? Example 3 actually has 3, but I'm going to start with a 2-part problem. I'm going to go with 5 over 6k minus 4 over 3k. These can get messy, all right? So I usually leave space after each term so that I have room to put the new fraction that I'm changing it to, okay? Both of these can be converted to 18k. That is the least common multiple, I still didn't give myself enough room, of the 3 and the 6, and obviously k. In order to change 5 over 6k to 18k, both pieces have to be multiplied by 3 over 3, which gives me now 15 over 8k. 18k, I'm sorry. In order to convert this piece to 18k, needs to be multiplied by 6 over 6. Gives me a 24. So now I'm just going to rewrite it so that it's neater. 15 over 18k minus 24 over 18k. which is whatever the difference of 15 and 24 is over 18K. So what is it, 9? Don't quit there. Don't quit there. 9/18 is -1/2. And there's your reduced answer. If you give me this, I'll mark it wrong. Okay? Have to reduce. And it doesn't matter if I have multiple, if I have 3 things being added or subtracted, you still are going to need to use the least common multiple to make the new denominator. Okay? You're still going to need the least common multiple to make that new denominator. What if they're big, bad, and ugly? That's example 4. Example 4. Here we go. And your book example, make sure you look at that one. But here's mine. Mine is going to be 5 over s squared minus s plus 1 over s squared minus 1. Least common multiple of all of that. How in the world do you do that? Okay, to find the least common multiple of polynomials, you need to factor them. Okay, so this one is s times s minus 1. You're going to need a lot of paper for these. This one is the difference of 2 squares. S plus 1, s minus 1. And remember, I don't know if you guys remember this, the least common multiple will be the lowest. Sorry, not the lowest. Largest power of any factor in the list or in the group. What do I mean by that? Well, we see the factor s to the first power. It appears 1 time. There's nowhere where it's squared or cubed, which means s is part of the least common multiple. We see s minus 1 to the first power here and to the first power here. In other words, it's appearing 1 time. Nowhere is it appearing squared. So it's going to also be listed in the least common multiple. And finally, we see s plus 1 appearing 1 time, maximum on either side. Therefore, s minus 1, s plus 1 is the least common multiple. Now, what that does for us is it forces us to take the original problem, and I'm leaving a ton of space, and change it so that it has this denominator. So I want to multiply this by something so that I end up with s plus 1, s minus 1. I want to multiply this by something so that it ends up with s plus 1, s minus 1. Okay, what are we going to multiply it by? This one, I have to multiply it by s plus 1. This one, and that'll give me whatever I need here. This one, I have to multiply it by s, and that'll give me that. So I know I might run out of time here, but I'm going to go quick. The first, this becomes 5s plus 5. This becomes s, 1 times that. The sum of which is 5s plus 5 plus s over that, s S plus 1, S minus 1.